So students, today we'll have an experiment to measure the diameter of a spherical object using the Vernier calipers. So this is the experiment in your class 11. This is the first experiment. So today we'll measure, this is our spherical object. This is a bob of the pendulum. So this is a spherical object. So we'll find out its diameter first. You can also find out its volume using the 4 by 3 pi r cube formula. You can also find out its volume. So now, as per the first experiment aim, we will be finding out its diameter. The aim is to measure the diameter of a small spherical or cylindrical object. So you can, if your school have provided a cylindrical object, you can also follow the similar procedure and find out the the diameter of the cylindrical body. So the important thing is in Vernier calipers, one is your zero error. If it has any positive zero error or negative zero error or no zero error. So zero error is an important thing. The second thing is about the least count. These two things the students find difficulty in writing the least count and the zero error. So these two things we will discuss first, then we will have the we'll measure the diameter using the Vernier calipers, and also we'll note down our read observations in a tabular form. So now you will find out the least count of the Vernier scale, right? So least count, you can use two methods. One method I have used the 1 MSD by the number of Vernier division. So this is our Vernier calipers, right? This is the jaws of the this is the Vernier one, and this is the main one, and they are perpendicular to the scale. Now you see there are two scales, right? If you look carefully, there are two scales. This one is the main scale. This is the scale over the this one, the big metallic strip. This one is the main scale, and the sliding one, you can see that there are also lines over this Vernier. So this is called Vernier scale. Now if you will count this properly, so this will be if you count this properly, 1 2, so it is 10 for my scale. So you can see, you can count of your scale, right? So 1 2 3 like that you can count, 1 2 3 like that, 4 like that you will count. Okay, so this is how you will count the Vernier. So if it is 10, so 1 MSD by n is the number of Vernier division. So if it is 10, I have divided 10, and 1 MSD main scale division. So main scale is, it's a your general centimeter scale. So each centimeter, you can see it is divided 10 parts. So one part is 1 mm. This is the main scale, right? So these are the main scale. So this is 1 mm. So each one is divided 1 mm, and from here 0 to 1, this is your 1 centimeter, and this is 0.5 mm. So each division is 1 mm or 0.1 centimeter. So 1 MSD means this is a main scale division, and 1 division is 1 MSD, 1 main scale division. So 1 MSD is 0.1 centimeter, is 1/10 of a centimeter. So 0.1 centimeter, we are writing in centimeter, you can write in millimeter also. So it will be 1 millimeter. Now 0.1 centimeter divided by 10, we are getting 0.01 centimeter. So this is the least count. There is another method to calculate the least count also. You can proceed in that way also. That is, let me tell you about the another method of the least count calculation. The least count, some of the books, the least count formula is given. So that is 1 MSD, 1 main scale division minus 1 VSD, 1 Vernier scale division. Now 1 VSD is, here in this case, 10 division 10 MSD right? 10 um 10 10 Vernier scale division is equal to 9 main scale division. Here you can see properly. If you'll combine these two zeros, you can see that this one is exactly, the last one is exactly coinciding with 0.9 division of the main scale. So 10 VSD. So 1 VSD is 1 Vernier scale division is 9 by 10, 0.1 main scale division. So 1 MSD minus 1 VSD is exactly 1 minus 0.9, that is 0.1 MSD. 0.1 MSD. 0.1 MSD means 1 MSD is 1 mm, 1 millimeter, or 0.1 centimeter. So 0.1 MSD is 0.1 and 1 MSD is 0.1 centimeter. So in centimeter also you can write, this will be 0.01 centimeter, or in millimeter also you can write, that is 0.1 MSD. And this in millimeter if you want to write, so in millimeter it will be 0.1 mm is, if you want to convert into centimeter, divide by 10, so you will get 0.1 centimeter. So this is another way of calculating the least count. Now what is least count? Least count is the smallest count, right? What is the need of this Vernier scale? These are the Viva question, right? So the need is, the least count means here it is 0.1 centimeter. That means without this Vernier scale, with the normal scale, we can measure the minimum 0.1 centimeter we can measure. We cannot measure a object's length less than 0.1 centimeter, right? So this is our least count, smallest count of this apparatus. So that's why this Vernier is helping us to reduce the least count, so that we can measure in the order of 0.01 even, right? So very minute measurement can be done. And what is such minute measurement? Minute measurement means, suppose the diameter is not exactly 2, it's just after 2 centimeter. So suppose this is 1, this is 1.1, and suppose your diameter is somewhere just crossed 1. So generally we take 1, but that if you want to measure precisely, that extra amount also we can measure with this Vernier, using the Vernier calipers, because we can measure with the precision 0.01. So if it will be in between here, so it will be 0.05. If it will be close to 1.1, it will be, let's say, 0.09. So like that. Okay, so this is how you will calculate LC, and what is the meaning of LC that I have explained. Now let us go to the zero error part, which is also very important part of your calculation. Now you will go to zero error part. So here in zero error, there are two types. One is positive, negative, another is no zero error. So how we will find out the zero error? This is our Vernier scale. Now we will close both the jaws, right? This jaw fixed one, this one is movable one, and this one, this how will you move this lower jaw? With this knob. This is a screw. So with this screw you will just rotate it, you will just move it forward and backward. You will able to move this Vernier one. And what is this upper screw? Upper screw, if you will tight it, it will fix. This one will tight, or it will be fixed at a position. You want to fix at a position, you have to move this screw, tight it. Okay, so just let us join both the jaws and check precisely that the first one is coinciding with the zero or not. If it is coinciding, no zero error, no issue. Just you will measure the diameter or the length of any given object, and you will not have to do the business of this zero error. So if your apparatus is coinciding, if the Vernier is coinciding with the main scale 0, no need of any zero errors inclusion. So you will not have to include any zero error in your table. Clear? Now The first case is if your apparatus having 0 error. That means the first line is not coinciding with 0 but little bit just crossed 0, right? So it is, let's say, ahead. This is your 0 mark. This is your 0 mark of the main scale. Now your vernier starts from here, not exactly 0. It starts from here. So what you will do, whatever the reading you will get, you are getting this much of extra, right? So what you have to subtract. This is your 0 error. You have to subtract 0 error. If I am writing E is my 0 error, so I have to subtract this 0 error. Remember this. If your apparatus is having positive 0 error, positive 0 error means that the vernier is not coinciding with the 0 and it is in the positive direction, or it has crossed this 0 mark of the main, right, somewhere ahead of this 0 mark. So in this situation it will having positive 0 error and you have to subtract this. How will you subtract this? How will you get this 0 error value? The 0 error value you will get, that you will find out the which line is coinciding of the vernier. Let's say 6th line is coinciding or 7th line is coinciding with the main scale, right? So if your apparatus is having 0 error, and if your apparatus is having 0 error, and after that what you will do, you will see out of these 10 lines which line is coinciding with the main scale. That is the very important. Suppose you will find that some of the lines are coinciding, but you have to check that properly which one is coinciding. You can use a magnifying glass also. So suppose let's say this one third, or let's say 4th line is coinciding. So how will you find the 0 error? The 4th line is coinciding means you will multiply 4 with LC. LC is 0.01. So this is the coinciding one, vernier coincidence, or the number of line, the line which is coinciding. Okay, coincidence line, number of coincidence line. This is 4 into LC. So it will be LC 0.01, 4 into 0.01. So it will be 0.04. So it will be 0.04. Now what you will do? This is your positive 0 I have told you. So this one is E. You are getting E. So if your 0 error is positive, whatever the result you are getting, let's say the result you are getting 2 centimeter. So from the result you have to subtract this value 0.04. So let's say you are getting 1.96 centimeter, right? So this is how this is in centimeter. So this is how you will use this 0 error. And what you will do with the negative 0 error? What will do with the negative 0 error? The negative 0 error means your vernier scale is behind the main scale, 0 of the main scale, right? So sometimes what will happen, if you will tight it properly, the first line will be in the left side of the 0 of the main scale. Suppose somewhere here. So that means it has some negative 0 error. So whatever the reading will come, the final result, from the result you have to add E. You have to add the 0 error. The procedure you will follows the same like this one. The number which is coinciding, multiply the LC, and whatever the number you will get, you have to add it. So you have to calculate the 0 error, right? So this is how you will proceed with the calculation of the least count, calculation of the errors. If there is no 0 error, you will write that my vernier scale is coinciding with the main scale, so no 0 error. Then we will come to the observation table. This is the observation table, which is very important. So at least 5-6 readings you should take, so that you can average out the diameter, right? So how will you write an experiment from the beginning? So first you will write aim. First you will write aim of the experiment. Then you will write the materials required. Apparatus and materials required. Material required. Materials required. Third one, you will write the theory or the principle. Then you will observation procedure. In the exam, if you can skip the procedure you can write in passive voice, like we have taken the Vernier scale and the diameter of the spherical object was measured. In this way you can, that you have done the experiment, you can write in the passive voice. Then your observation table, then your calculation part. If any graph or any diagrams will be there, you will do that just after the observation, and that should be done in the white page of the notebook. Then the result, then precautions and sources of error. So this is how you should go with these headings: precaution and error, sources of error, So in this way you will write, right? So the observation table, we are at the observation table. So observation table, what you will do, how will you take the readings, that is very important. So we are finding out the diameter of the given spherical object. So this is our spherical object. This is the steel spherical object. Okay, and how will you do that? How will you measure the diameter? This is the upper jaw and this is the lower jaw. So you can put it in between these two jaw, and you have to just tight it, make it tight so that it will not fall down, and try to keep it in between the jaw properly, so that it will be at the midpoint. Okay, so now it's in between the jaw, it's in tight. Now you have to look at the reading. So how will you take the reading? This is very important. Now see, this is very important. How will you take the reading? This is very important. So the first line where it is coinciding with the main scale, you have to take that main scale reading. If it is coinciding or it has crossed this line. Suppose this is the line, the Vernier line is suppose somewhere here, so you will take the previous line of the main scale, right? Either coinciding or main scale should be before the Vernier should cross it, so that you can take the main scale. So what is this line reading? If you can see clearly, see, this is 2, this is my 3, so this line is coinciding approximately. So what will be the reading? This is my 2.5 main scale. So what shall I write in my main scale? My main scale will be in 2.5, right? Now number of coinciding Vernier, right? Which line is coinciding in the Vernier, that we have to see. That you have to see which line is coinciding. That one you have to see properly. You can use the convex lens also, magnifying glass also. Suppose this line, 5th line, or this one, 6th line is coinciding, 8th line is coinciding, right? So we'll write this is 8. The line which is coinciding, you will write 8. Now this one is V into L. This is Vernier scale reading. That one will give you LC into N. So LC is our 0.01. We have already found out. So 8 into 0.01, this will be 0.08. Okay, now the diameter. So this is the main scale and this is the just crossed main scale. So this one is the Vernier. So we have to add it. This one m plus with add it. So 2 plus 5, 2.5 plus 0.08. So this one will give 2.58 in centimeter. Right. Now as my apparatus has no zero error, so I will not write. The corrected one will also be same. Now imagine I have some zero error which is, let's say, 0.03. Let's say positive zero error. I have some positive zero error and the value is 0.03. So what I'll do, I'll subtract this 2.58 minus 0.03. So my value will be 2.53. This is my result. Now I'm not doing the experiment repeatedly. You can do it about 5 times. What you will do, again the same thing, you will, because you will again keep it in between the jaws, you will tight it, you will find. So almost every time almost this one will come same, almost 2.5, sometimes maybe 2.6 may come, 2.4 may come, but it will not vary from it will not be less than, it shouldn't be less than 2.4. You should repeat it, or it shouldn't be greater than 2.6, because on an average you are getting 2.5. Okay, so again your Vernier coincidence may change. Again this will change, this will become 0.07. so you can add it, it will become 2.67. if you are having zero error, 0.03 positive zero error, you will subtract it, so you will get 2.64. so like that you will get, suppose 2.54, 2.56, like that 2.52, like that you are getting, suppose 5-6 reading you take. Right, now your observation table, you also fill up all these things, you fill up each case you fill it up. Now your table is done. Right, now what you will do, the calculation part. So the calculation part, what you will do, in calculation part, just you average out all the D. So D average, diameter average, is equal to, so 5 readings you have taken, so it will be D1 plus D2 plus D3 plus D4 plus D5 divided by 5. So what you will do, you add it up all these numbers, let's say 2.53, 2.64, 2.54, 2.56 and 2.52. right, so for these values generally this will become, right, so okay, so now divided by 5, so you find out the average value and this will be in centimeter. Now this, after the calculation, you can write the result. So what do we write in the result? That the diameter of the given sphere, the diameter of the given sphere, diameter of the given sphere is found to be whatever the result, whatever you got, that centimeter. Right, so precaution and sources error, you can write two precautions and sources error. Like precaution, you should hold the sphere properly in between the two jaws, and you can also write precautions, the reading should be properly taken with the, and sources of error may be due to the, right, if you have not observed carefully, so there may be little bit error, so you can write sources of error and precautions. Right, so this is all about to find out the diameter of a given sphere. So just I am explaining, I will make a separate video for that, but just I am explaining how will you measure the internal diameter of a cylindrical object. Right, How will you measure the internal diameter of a cylindrical object? So next is how will you measure the internal diameter of a beaker, and how can you measure the volume? So just let me explain you in this video. To measure the internal diameter, you will use this upper jaw. This upper jaw, you will keep it in between this diameter. You will just make it expand, and when both the jaws are touching, just like this, you will note down the reading same way. The same way you will note down, same way you will write the zero error, and the table you will mention. And how will you measure this volume of this beaker? Suppose this is a beaker, just a plastic bottle, but it's like a beaker. So how will you measure the volume? So diameter, you know that volume is pi r square h. So length you have to measure, right? So you can measure length like this also, keeping in between two jaws. You can measure like this also the length, right? Or because here little bit problem may be there, or thickness may be there, so better is to measure the length. To measure, use this one to measure the your depth, right? So what you will do, you will just put like this, keep on moving this slider, and when it will touch, just touch the bottom, just touch the bottom, you remove it, then take the note, then note down your length. Let's say it's around its depth is around, what is the reading? Yeah, 9.8, or yeah, 9.8, around 9.8 centimeter. So once you know the length, diameter is known to you, so pi r square h, you can measure its volume. You can measure the volume. Similarly, if only cylinder depth, cylinder outer depth, outer diameter and inner diameter. So outer diameter you can measure like this. Just you can keep the cylindrical object in between the two jaws. You can note down this MSR, and same procedure you can follow. You can measure the cylinder outer diameter. The inner diameter you will measure, again you will take the, similarly you will use the upper jaws. You will keep in between the upper jaws and expand it. You will measure the inner diameter. Like that you can use the Vernier scale in different way, right? Any confusion, any doubt, you can write in the comment box so that I can make another video clarifying your doubts. See you in another video. Thank you for watching. Bye bye.